तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
In the previous lecture, I helped you get a glimpse, or you may call it a bird's view of the overall computer system. In this lecture, I will try to narrow down to again an introduction, but towards what we may call as introduction to software and hardware. Okay. We had talked about this earlier too, and we will continue in fact to keep talking about this throughout this series of lectures. We started saying that hardware in fact is the core of a computer system, okay, and that essentially the hardware consists of CPU, memory and I/O. This is the picture I was giving you yesterday. Good. Then towards the end was also telling about the layers and layers of software, so that really the user who is just outside the whole thing is getting a view, so that the inner details of the hardware, the more and more machine oriented information of hardware is hidden from him. In fact, that is the main purpose of software, that is the hardware details are softened and the user is enabled to get some view from his point of view, not from the machine point of view. Okay, this is the main thing. Good. Then we also saw a few other things, saying that ultimately for any program which the user develops will have to be run by the hardware, and at that particular one what you have essentially are machine codes. Okay. So, MC stands for machine. So, that is what is taking place at the hardware or the inner layer level. But these machine codes are very hard to remember, okay, because essentially that will be a string of numbers. If it is binary numbers, a string of zeros and ones, it is very hard to remember. Okay. So, to enable the user to remember, the other to aid his memory, that is generally called mnemonic codes, said the particular program can also be written in a different language called assembly language, and the codes developed thus are assembler codes. Well, that is one level away from the hardware or the machine part of it, but the whole thing can further be simplified, right. And then I said high level language codes, at that point actually they are called statements. Okay. Statements can be made so that an expression, a function can be given, so on and so forth, that is a mathematical expression can be given making use of the high level language. And I also mentioned in that context like Fortran, BASIC, Pascal, okay. These are the things which in which the program can be written. Now, ultimately, since the hardware is going to run the whole show, because that is in fact a core of it, that is the CPU memory I/O, the hardware part of it. whatever the user may be doing, whether he is doing whether he is developing the program at the assembler level or at the high level language, ultimately one must provide some mechanism so that these codes can be translated. Okay. It is not really necessary that one must translate high level language code to assembler code and then to machine code, it can also be direct. So, this is one type of translator. That is from assembler code to machine code, and then high level language code to machine code will be another type of translator. The point is here, this is in one language and you have the machine language here. So, from one language to another language, that is a translator. Okay. That is what as the name itself suggests, that is translation takes place there, right, from one natural language, say from Tamil to Telugu or English to French or something like that. So, the same thing holds good here. However, these translators are somewhat different. Okay, now, what difference is that? For instance, when you translate from this level to this level, that is assembler level to machine code level, they are specifically called assembler itself. Okay. That is from assembly language you translate. So, the program which translates the assembly language code to machine code is called assembler, whereas from the high level language code, when these are translated, they are called compilers. It is in fact one particular one. Apart from compiling, there is another aspect also, that is called generally interpreter. In fact, this term not very different from what we already know. Translators we know, and then interpreters also we know. Hope many of you would have followed. From one language to another language we will provide the translation, most of us follow that. Now, when a person speaks in one language and when the translator listens to and immediately translates into another language so that the other person may listen to, that thing is, though it is translation, it is really called interpretation. Okay. For instance, you would have seen when these let us say Russian dignitaries visit our country, there will always be someone between the Russian dignitary and the corresponding Indian dignitary. He will keep listening to this person speaking in Russian and immediately he will keep translating. He is not called actually a translator, he will be called an interpreter, because he keeps listening and immediately he keeps translating to the other person. So, you also have from high level language to machine code to interpreters, okay, that is one class. Also you have high level language machine code which are translators, which in fact come under compilation, that is compilers. So, for instance, if there is a program written in Fortran, you need a Fortran compiler. If a program has been written in say Pascal, you need a Pascal compiler. All this so that finally the machine codes can be got and the particular program can be run. Okay. Specifically in the case of BASIC, generally we make use of interpreters. BASIC interpreters will be there. Well, there are some reasons for that. Okay. Now, in general, translator is the one that is needed essentially to see that the codes which are at language further away from the machine codes, they can be translated. Good. Now, having said this, why is it that let me put it this way, is it necessary for every person to keep developing the translator? Absolutely, it is not necessary, because given a language, let us say Fortran, given a language, and when a person knows the details of the language and he keeps developing the program, if there is a Fortran compiler, that is going to do the translation. So, that particular compiler which does the translation from Fortran code to machine code is going to be fixed, whoever may be the user. Anyway, that particular Fortran compiler itself is another program though, right. The same way, for a program written in Pascal, you need a Pascal compiler. So, that again is going to be fixed for whoever may be the user. So, the user really need not bother about developing these translators. So, now you can see that from starting from the hardware, we are going to one level of software which is permanently there with the system, say Photon compiler, say the Pascal compiler or a basic interpreter. Okay. So, that the user can write appropriately and then make use of whatever that is needed, right, to translate to machine code, so that the program can be run subsequently. Now, you can see that though we said the core of the hardware is CPU memory IO, which I would just call it as bare machine, okay, bare machine. Now, with this kind of translators added, now we are going to one level of software away from the hardware, and now from a machine, from the simple concept of machine, we are slowly graduating towards the concept of system. Fine. Now, the system not only includes the basic core of CPU memory IO hardware, but also this kind of translators which is part and parcel of the entire system. Agreed? Fine. Now, the same thing, whatever I have said here also holds good. Suppose I have written a program, and that program essentially is for okay, given some data, let us say angle theta, okay, that is the input to the system. Let me put it, theta is the angle system. Now, I have written a program, okay, call it P, and the output of this is sine of the theta. Now, given this, any particular person who wants can make use of this. He need not keep developing that, right. So, you can see that programs like this can be written, and we can create a library of programs okay, which again form part of this particular system software, and these programs can be made available all the time to any user. Okay. So, you can just see that from simple hardware we can add some extra facilities, so that high level language programs can be written, so that ultimately the computing system can run the machine code. That is what it is capable of. Okay. And then in addition, you can also think of other programs such as this. Now, this is one thing. Another thing is, take a look at this IO. There would be different types of IO devices. You will be having a printer, you will be having a plotter, okay. You will be having of course a keyboard, then you will be having the display unit. Now, what about the programs for these? For instance, keyboard, you would need keyboard routine. Okay. Well, you will keep seeing that quite a few jargons keep coming, like now I have introduced a term routine, okay. Keyboard routines. Now, these routines are, just take them as again program, right. Keyboard routines, then for display you would need display routines, okay. That is the keyboard routine. Now, here you have the display routine. Now, similarly for printer you may be having the appropriate printer routines and so on and so forth. Now, essentially these may be called as utilities, which means these are things which are quite useful, or these are things which can be utilized by the programmer. again these keyboard routines, display routines, printer routines, all these things you need for accommodating different types of I/O devices. Agreed? Now, any user need not keep developing these again, like he need not keep developing say certain functions like this, that can be made available as a standard thing as part of the whole system. As in the other case, yes, the system can come apart from this, can also include the software, so that Fortran compilation can be done or Pascal compilation can be done like this. You have the translator, you have certain special function programs, like this library of programs. That is, for instance, I may have developed some program or a series of programs, and I may keep them available for use by others, right, in addition to these which would be used. These are again needed basically to see that the system can be used by any user. If you have say a dot matrix printer, a dot matrix printer routine and interface will be needed. If you have a laser printer, then you need a laser printer routine and the necessary hardware interface for that. All these are standard. So, now you can see that from a bare machine which just consists of CPU, memory and I/O, the whole thing has graduated to system which obviously includes layers and layers and layers of software. Now, ultimately you would find that any user is not really going to be bothered very much about the inner hardware, but after some layers. Let us just take one particular one of these layers, right. There may be many more like this. That is, it comes to deal with an OS or just an operating system. That is, finally, it is not just a machine consisting of a collection of few hardware things like CPU, memory and I/O, but also quite a bit of software which are available as part of the whole system. Now, talking about operating system, this itself has its own commands, right. Just as we were talking yesterday about some instructions for the processor CPU, now we can talk about, they are not called instruction, they are called commands in this case, commands at the system level, and this itself defines a language. Now, you can have some hardware and you can have different layers of software and come up with one operating system, and with the same hardware and different set of layers of software you can have another operating system. For instance, let us say we have an Intel 80 say 486 based system or a Pentium system. So, that is just the hardware part of it. Now, layers and layers of software can be added, and you can have, for instance, a DOS operating system, or maybe Windows operating system, or you might have a Unix operating system or whatever it may be, and the core of the entire thing may be just the same. Just these layers of software, they make all these, and if one uses these particular things, then DOS commands will be used, Windows commands will be used, Unix commands will be used. Now, these are the things. So, this is how we go, or I may put it as we graduate from a simple machine to a complex system. We were talking about a system. Let us go back a little further and then see. Essentially, it said hardware ultimately runs machine codes, and that user develops his program or codes in some language, whether it is assembly language or whether it is say a high level language like Fortran, Pascal or C, whatever it is. Good. Now, since the program is written in at this level, okay, and that is the starting point of the whole thing, that is some language. So, this particular one is also called a source code or source level, okay, that is a source code. Now, when this gets translated, then ultimately it is going to be in machine code, and that in fact is called object code. And later on you will find that these codes are going to be stored in the form of files. So, we talk about say something like a source file or an object file, and generally when you take a printout of this, let us say the original program, then that particular thing is usually called a source listing, which will keep giving information about how this whole program was written, what are the assumptions made by the programmer, etc., etc. Ultimately, at the machine level, it is just the object code. Good. So, later on we will talk about the source file and object file. Now, going back to our thing, that is a system. I was mentioning that we graduate from a machine to system, and then I also mentioned about the OS or the operating system. And then I said you can start with any machine, and then depending on what you add, you will be getting different types of operating system. I also gave you a few examples. Okay. Inside in the core you may be having the same processor, but then you can also end up with different operating system. Good. Then, so we may say that starting with the machine hardware core, we are going on adding layers, and then we are talking about a system with which the user deals. This is an important thing. In other words, we are adding quite a few things here, and so this software which would be part and parcel of the system, that particular thing we may call as system software. Now, this particular one could be seen as different from what the user actually writes, which we may call as application software, because the user is very much concerned with the specific application. Okay. So, the application software is what maybe one kind of user will write. For instance, they again, like we talk about layers of software, you can also talk about classes of users. Okay. One particular type of user may be developing the system software, another particular type of user may be developing an application software, and a third type of user may just be using all these things together. Like for instance, a particular person designs the hardware and then somebody adds layers and layers. Okay. So, the ultimate user is going to be outside of the whole system, and then you may be talking about layers of application software, layers of system software, etc., and finally, you have the hardware which is the core, and all these details are going to be hidden, and what the user will be doing will be making use of those system commands, that is the operating system commands, and a few commands or instructions whatever may be, which this particular application package asks him to do. Okay. Well, it all depends upon the kind of applications, how exactly the details will be worked out. Good. Now, talking about operating system, I would like to mention a few types of operating systems or classes of operating system. The reason is, it all started originally with what is known as batch processing, because the details of these operating system will vary depending upon the kind of system one has. It all started with batch processing when the currently available concept of desktop computing was totally absent. That is when in fact the processor in fact got the name CPU or central processing unit, because everything was centralized, say in a computing center or something like that. Okay. Today we do not talk about computer center, it is all distributed. It is all distributed even to the level of one computer on each desk or even lap now. Okay. Now, we talk about laptop, soon we will be having finger top computers too. Okay. This is how things are going, but in those days when we talked about a computer center, when all these things, hardware resources, what are they? CPU, memory, IO devices, all these things, they were all centrally located in one place, and people will be submitting their source programs, okay, these source programs, maybe a deck of cards and subsequently as files in floppy and so on. Now, all these, each user's program, okay, it will be called a job, okay, user's program will be called a job, and these jobs will be listed according to some priority, and a batch will be created, and one after another these jobs will be processed. Okay, this is how the operating system came about. In fact, that time it was even called the JCL or job command language. Okay. Job command language is not different from what we are talking about as operating system commands and related to that. Okay, that is the batch processing, meaning the system was taking only one user's program and it was doing it, and some priorities will be allocated to that. And then subsequently, when say more number of users had to be catered for, what was known as time sharing concept came, meaning the system will turn its attention towards different users and it will share its time among these users. Okay. Here the user may be able to interact with the system. Now, unlike in this particular case, here the jobs are submitted, they are all queued up, the user is not in fact interacting with the system. In the case of time sharing, usually the user may be able to interact, and also if the user is online, this will be called an online time sharing system, and the operating system for the batch processing is was different from the one for time sharing. Okay. So, depending on what exactly the configuration is, you would see that the operating system characteristics also will keep varying, and that is fine. These are all from data processing point of view. Remember, earlier I was mentioning generally the broad spectrum, in which at one end we had data processing, at the other end we had control applications. Then the computers from very large mainframe, they have come down to some mini size. The mini computers, when they came, the first say series of computers were used, mini computers were used for what are known as control applications, specifically process control application. Okay. Now, you can just see, depending on the configuration of the system, earlier I said, now depending on the kind of application, that is for data processing, now this is for control application. Now, the operating system used for process control will have slightly different characteristics altogether. Okay. That is one thing. And then apart from for instance, I will give one typical application, say in petroleum refineries, right. There will be transducers, and these transducers will help analog signals picked up from something like 1000 or 1024 different points. All these signals will be coming to the particular system, and the process will be controlled by the whole thing. Okay. Now, this is totally different from this. Here the data comes in real time, right, from the external world, whereas in these things generally, say in batch processing, certainly it is all data which is frozen. In time sharing, it could be either this or that, right, process control. The moment they saw that computers can be used very effectively in process control, then the concept of real time came, that is real time processing, in the sense, well, you are not only taking signals from the external world, say what we may call as live signals, right. You may also take the signals, process them, and return the processed information back to the system in real time. Now, what is real time? It is a very relative definition. There is no such thing as 1 second is a real time and 100 millisecond is not. It all depends on the application. Okay. So, the system can wait for a particular period. Within that period, if the processed information comes back, then it is real time. Okay. So, we have now batch processing system, time sharing system, okay, process control. This is usually an online system, and then real time system. Now, the operating system for each of these will be different, because each of them are having different characteristics. Now, what is the latest? We talk about distributed processing and distributed systems. Okay. Now, that has come about mainly because of these desktop computers, and the process can be distributed. Then we talk about network systems, and so now of late we have got to talk about an operating system for the network, or just it is called a network operating system, network OS. So, like this, all depending on the configuration of the system and the application for which you will be having different types of operating systems. Good. Now, this particular one, as I have said earlier, we can talk about layers and layers like this. So, the inner one is hardware, at the outer one we can put it as application as part of the system. There is some application software which the user interacts with, right. Now, you can see that the inner one is hardware. When you go out, it is going to take more and more time. A program, if it is run at this level, it will take less time. A program, if it is run at this level, it will take the maximum amount of time. Why? Because this one will call for some program execution at this level, which in turn will call something at this level, which in turn will call at this level, like this it will keep going. So, if that is running an object program would be the fastest. And so, in fact, in some of this real time processing, okay, real time processing, it will be required that at least some portion of the program will have to be written and run only at the innermost level or the object level, because time critical applications, that is what the real time is about. So, the furthest from the system, so let me note it that furthest or farthest, let us say farthest from the core or the hardware, okay, slowest will be the response, slowest the response is. Okay. So, this is important. Okay. So, because this particular thing will have to be had in mind when we develop the programs. Okay. So, there is no point in going on adding layers and layers if ultimately you find the response from the system is going to be very slow. So, what for instance, let us say one application, let us say translation. Suppose I am interested in developing a translation system, let us say from one language to another language, let us say Hindi to Tamil or something like that. Now, if the Hindi input is given, if the Tamil output is going to come 2 minutes later, who is going to wait for it? Is it not? So, this is similarly like this also. Now, this is one way of looking at it, that is we are talking about shells, okay, that is layers and layers, which is very much like an onion like, okay, layers and layers like onion. This is a shell like structure, okay, that is you have a shell and then you think in terms of inner shell and outer shell and so on. So, we can go on talking about layers and layers of software. Now, there is just another way of looking at the whole thing. Now, what is that? Which is in a hierarchical manner. Okay. So, it's the same thing we are going to write in a slightly different way. Now, I am talking in fact, I am mentioning this because there is absolutely no uniform way in which we can describe this. For instance, it is not that as if this one will not have direct access to this, something at this level need not really go through all the shells, some of these may directly access also, okay, all those things are there. So, it is not that it is not possible in case of onion, for instance, outer shell has to be removed totally to go to the inner shell, okay. It is not like that here. So, it is only some kind of a imagery you are trying to build. Now, talking about just the software, right, which is what we are talking about. Now, I said the two things, that is system software and application software. Now, we can mention the two things as this, that is at one end we have the system software and at the other end we have the application software. Okay. Then this would system software at the highest level would include the operating system, and then from the user point of view there may be some translator, okay, that is also very much part of the system. And the translator I already mentioned, it can be a compiler, okay, or it can be an interpreter, right, interpreter. Then when talking about compiler, for instance, I can talk about the Fortran compiler, right, or a C compiler or a Pascal compiler and so on so forth. Okay. Same way with the in case of interpreters also. Now, this is at the system level. Now, go to the application level, where there can be many things. Okay. The same way you can talk about many levels, just I will indicate a few things. For instance, in Office application, one would be using a word star, okay. Like this, there may be many things here. We can talk about spreadsheet and so on so forth, and somebody else may be using a DBase program, DBase package. So, here you will be interested in knowing, though they call this as a software DBase application program, in fact that itself is a language by itself. Okay. So, the moment a person is using, that is a user is using at this level the DBase application package, really he is dealing with one language, one specific language which is specific to that particular type of DBase. Good. So, this is how things keep building. So, now you must know that there are many ways of looking at it. In the shell like I have given you, and then in the hierarchical manner also we can talk about, all right. Now, for instance, the operating system we can further divide into many things, okay. Something will be dealing with say file handling, right, because ultimately I said a source file, okay, there are different types of files like that. So, the routines or the programs needed for handling these files, and then I was also mentioning about the different devices now earlier. So, those routines for handling the respective IO devices. So, all these things will be coming under that. Hope now you have got some picture about what essentially the software part of a computing system is. Earlier I said in this lecture you will get a bird's eye view of software and hardware. So far we had seen about software. Now, let us take a look at the hardware. As I said earlier that any system must be studied from user's point of view. So, we will follow the same thing here too. Now, what does a user see? He would be interacting with the system, and so he sees physically a keyboard, display, and then printer, and inside the system he will also be watching, if he opens up the system, some CPU board, some memory board and IO board, essentially because these are devices or IO devices, and these IO devices can how to interact with the CPU and memory, and so these devices need the extra interface, okay, extra interface, and essentially these IO boards provide the necessary interface. So that CPU and memory essentially forming the system with a set of interconnecting lines generally called bus, okay, particular thing. So, the I/O is very much part of the system now. What is on the bus is actually the I/O interface, and then the devices are there as part of the real world, okay, through which the user interacts. Good. Now, there are different types of keyboards. Similarly, there are different types of displays, printers and so on. And what is more important is we talk about the CPU and memory, and then in the previous lecture also I was mentioning that CPU and memory, these will interact, I will say, as electronic speeds, whereas these devices which are in the external real world, they will not be able to interact at that level, and so we bring this interface, that is why it is even called an interface. We bring this interface so that at this point, okay, the communication between these will be at electronic speed, whatever may be the speed at which these actual these devices actually operate. And so now we have to talk about a processor, that is a CPU, and then the memory, and then the I/O, and also now for the first time we have been seeing that we are talking about the bus or the set of signal lines. Okay. Now, this in fact is the total system, and for the moment we will forget about the software, because that will also have to be studied slightly from a different perspective. Now, when we talk about this, then obviously the signal lines, okay, these must be defined, that is actually the sequence in which the signals go over the lines must be defined, right. Now, when we have a common set of signal lines like this, then obviously there must be something which controls the whole show. So, generally what we find is CPU is usually the master of the bus, and that in fact will be orchestrating the flow of data or the signals over these lines. And memory is always the slave, because it has by itself nothing much to master over. The I/O is usually the slave of this entire thing. Now, I said usually CPU is the master and I/O is usually the slave, memory is always the slave. So, in this particular way we would be talking with reference to this set of signal lines. The CPU will demand, say, memory for something, and the memory as a true slave will respond, or the CPU may demand something with I/O, and the I/O usually as the slave may respond. But there may also be situations when I/O may demand, in which case the generally it is the CPU which will be responding for a short while, but usually this is the master and usually this is the slave. Occasionally this may become a master and occasionally this may become a slave. Okay. Now, these are the different I/O, we may put it as I/O transfers, which may take place making use of the what we call as protocol of the signals which are defined for these lines or the bus. Okay. Good. Now, let us go back to these interface boards. Depending upon the type of keyboard, the appropriate interface is required. Now, talking about keyboards, we can talk about, let us say, just the keyboards alone, okay, just put this keyboards. We may talk about some keyboard which generates a code, I will call them as ASCII codes, okay, ASCII codes. Now, what does it mean? When a key is pressed on this keyboard, For that particular key there is one code, unique code that is generated, that is for a particular key there is a unique code that is generated, and that in fact is some unique code in the particular set called ASCII. Good. ASCII, if you want to know, it is American Standard Communication in American Standard Code for Information Interchange. Okay, that is what it is. Okay, when A is pressed, there is a specific code for that. B is pressed, there is another specific code for it. Now, precisely the CPU is only looking for that code which defines a set of signals which go to that. So, let us say the CPU demands from the keyboard something, and the keyboard responds, let us say. Now, how will the keyboard respond? The user will respond say by pressing a key, and the CPU collects actually the code. By looking at the code, the CPU knows what key has been pressed, right. Now, like this, now the keyboard which make use of this is called just an ASCII keyboard. Now, there can be different types of keyboards, and then it can be a pressing type of keyboards, it can be different sensory manners in which the keyboards can be designed. Fine. We will not go in much detail at this stage, right. Now, depending upon the keyboard type, the interface is required, that is more important. Similarly, now you take for instance the printer, the printer. Now, the printer may be again different types, so just to give a few things. Now, there may be a dot matrix printer, there may be a line printer, there may be a say a laser printer, then there may be an inkjet printer. Now, depending upon these types of printers, again the appropriate interface circuitry is needed. Now, that is what we are talking about. Now, whatever may be the type here, as far as the communication between the CPU and I/O must be uniform, then only at this level we can talk about some standard, otherwise there will be problem. So, the CPU to this interface must be standardized, and all the I may call as the idiosyncrasies of the respective types here will have to be absorbed here. In other words, we are going to see that the details of the device, these devices or kinds of devices will be hidden from this side. That is what precisely the interface is doing. The same thing about display for that matter. Now, just for instance, the display, you can have a normal raster scan display, that is what is what everyone knows in with reference to TV, or it can be a different type of display. For instance, vis-a-vis you have a random scan, and there are different names for that, which we will talk about more in the next lecture. Now, depending upon the types of displays, again these interfaces will have to be different. So, precisely whatever I was talking about, printers hold good for the displays too. So, more about this displays and some more about this hardware details we will cover in our next lecture.